Alright, class, last section of the year/unit. Let's get rid of that. 8-8, writing linear equations. So yesterday we talked about slope-intercept form, and we graphed those equations. Well, now they're going to give us information about the graph, or the slope, or some points on the graph, and we are going to write the equation, what the equation would look like to match that description. So again, yesterday they gave us the equation, we graphed it based on the equation. Today we are going to be giving information, and then we are going to write the original equation. So let's start off with some basic ones for this unit, or some more straightforward ones I should say. So yesterday, slope-intercept, y equals mx plus b. It's written up here. Okay. Our m was our slope. Okay, so whatever our slope was, remember that went in front of x. So that was our slope. And then the b was the y-intercept, or the number where it crossed the y-axis. So I'll put y-intercept and just abbreviate. Okay, so if I know these numbers, the slope and the y-intercept, I'm just going to put those numbers into my slope-intercept equation, and that'll be my answer. So let's look at example 1, part A. They tell me the slope is half and the y-intercept is a -5. Well, I'm just going to plug these numbers into my formula. My slope goes in front of x. What's my slope? 1/2. So y equals 1/2 x. I'm going to add on whatever my y-intercept is. Well, my y-intercept is -5, so I'm going to add on a -5. Well, adding a -5 is the same as subtracting a +5, if you want to look at it like that. So the best answer would be to go from this and rewrite it like this. Alright, so the best answer is y equals 1/2 x minus 5. But again, we're just plugging in the information. The slope goes in front of the x, the y-intercept goes at the end, or added on the end. What if they give us a graph now? Well, looking at this graph, I can identify a couple things. What is the y-intercept of this graph? Where does it cross the y-axis at? Well, it crosses right here at 3. So my b, or my y-intercept, is 3. My slope, if you remember, is rise over run, or vertical change over horizontal change, or y2 minus y1 over x2 minus x1. Either way, I'm going to pick 2 points on this line here, and this seems to be good. We're trying to find good intersection points, and this one's kind of close, but doesn't hit exactly in the corner of the box. We're trying to count how much did it change vertically, how much did it change horizontally, and that's my slope. Okay, the rise or the run. Well, from left to right, going from this point to this point, I went down 5, so that's a -5, and I went over to the right 4, so right +4. There's my slope. I just have to count from one point to the other point. Down 5, so -5, to the right 4. And now, once I have this information, it's exactly the same as part A. I'm going to plug in my slope in front of my x, so y equals -5/4 x. I'm going to add on my y-intercept, which is 3, plus 3. Okay? So, slope-intercept form, if you know the slope and the y-intercept, or they give you the graph and you can identify the slope and the y-intercept, these are not too difficult of problems. Just got to plug them in to the 2 places, slope and y-intercept. Okay? Now, it gets a little more complicated when they give you 2 points, or they give you a table of points on the graph. But again, not horribly bad. So first of all, let's write down the point-slope form. This is the point-slope formula, or form. Okay? And this is given to us if we know a point and we know the slope, or we can find the slope. Given it's a point-slope formula, it tells you the 2 things you need, a point and a slope. Alright? If we have a point and a slope, the slope is going to get plugged in for m. Right there, whatever your slope is goes in front of these parentheses. And your y1 and your x1 are just one of your points, or a point on the line. Okay, whatever your x point is goes here, that number. Whatever your y number is goes there. The y and the x here with no number, no subscript by them, it's called, those are always there. Those don't change. Okay, you don't plug a number in for those. when you're writing the equation. So let's see what this looks like. Example 2. Write an equation for the line that goes to this point and this point. Well, for point-slope form, I need a point and a slope. I have 2 points. I don't have a slope, but we can find the slope. 2 days ago, 3 days ago, I don't know, a couple days ago, we talked about the slope formula. y2 minus y1 over x2 minus x1. We should all have that in our notes still. I told you this formula would be following you. Oopsies, mouse went off the pad there. Be following you for the rest of your mathematical careers in high school. But we're just gonna find the slope given 2 points. So here's my x1, y1. See if I can write it. It's a little thick, but x1, y1. And this is my x2, y2. Probably my best handwriting in the year. Okay, so I'm just going to plug these numbers in. So 5 is going to go first. So 5 minus 8 over negative 2 minus 4. You use a calculator if you know the answer. 5 minus 8 is a negative 3. Negative 2 minus 4 is a negative 6. And we talked about this before. Oops, bad 6. Negative divided by negative is a positive. And what does 3 over 6 reduce down to? 1/2. So our slope is going to be a positive 1/2 because, again, a negative divided by a negative is a positive. So now I have my slope. And I have 2 points, but you only need 1. Let's pick the first point just because they're both positive numbers. I don't know. I don't have a really good reason. Both of them will work. Doesn't really matter. Let's write it in point-slope form. Okay? So here's what it looks like. Y minus y1. So I'm going to write it as y minus, what's my y1? Well, that's 8. Equals, go back up here, m. Well, m is my slope. What was my slope again? 1/2. Parentheses x minus x1. x1 is 4. Alright. So there is my equation of a line that goes to these points. Okay. This would be an equation. But if they ask for it in slope-intercept form, meaning y is by itself, we have to do a little manipulating. So to get y by itself, I want to distribute whatever my slope is. I'm going to distribute to both numbers here. Distributive property we talked about a long time ago. 1/2 times x is 1/2 x minus 1/2 of 4 is 2. And now my final step is to get y by itself. So what would I do to both sides to get y by itself? I would add 8. So plus 8 on this side, so that's gone. I'm going to add 8 on this side. Negative 2 plus 8 is 6. So there's my final answer in slope-intercept form. So I told you, this one took a little bit of work. Again, it's the last section here. It's going to call on a lot of rules that we've talked about earlier on this chapter, even earlier on in the year. We're going to use the slope formula. Okay. We're going to plug it into our new point-slope form. Then we're going to distribute. And then we're going to solve the equation for y. So again, that's 4 different chapters that we've talked about. Or at least 4 different sections all in one here. Alright, find the slope, put it in the formula, get y by itself. Alright, let's do another example similar to this, but they're going to give you a table. Well, a table is just points. These are all coordinate points, x, y points. Okay, so I can do, y2 or x1, y1, x2, y2. But you can pick any points you want. It's going to work out either way. Let's do, the first two just because they're together. Alright, so this is my x1, x1, let's do my x2, this is my y1, this is my y2. So it's the first y and second y, first x, second x. I'm going to plug it into the slope formula. Look over here, this is what I did. Okay, plug it into the formula. 1 minus a negative 2 is the same as like 1 plus 2, which gives you 3. And 8 minus 4 is 4. So there's my slope, 3/4. Not that difficult as long as we remember the slope formula. We spent the whole day working on that worksheet. So my slope is 3/4. I can pick any point that I want. If you look down here, they use 1 and 8. They use this point. Let's go and use another point. Let's just use the top one. I want to show you what happens when you put a negative in there. Alright? All these answers are going to end up being correct. But I do y minus y1 is negative 2. Y minus a negative 2. We'll come back to that in a second. You should see what's going to happen here. Equals my slope, m, which is 3/4, parentheses x minus x1, which is 4. Alright? So this is very close to being correct in point slope form, but I got to simplify this. When you subtract a negative, that's the same as adding a positive. So I'm going to do my final answer here. We've got y plus 2 equals 3/4, put a slant, parentheses x minus 4. Now, if I want to put these in slope-intercept form, and you get y by itself, y by itself, when I do this one and get y by itself, and I also get this one with y by itself, they're going to be the same equation. They look different now, okay? But if I do it really quickly, I distribute this, I get 3/4 x minus 3/4 of 8 is 6. Okay? If I do 3/4 over here, I'll do right below 3/4 x, and this is going to be a minus 3. 3/4 of 4 is 3. Now look what's going to happen here. Over here, I have to subtract the 2 over to get the other side, so it gives me a minus 5. Over here, I have to add the 1. This is also going to be a minus 5. So in slope-intercept form, they're going to be the exact same equation. Right now, in point-slope form, they look different, but they're really the same line. Alright? So you can pick any one of these points, and it'll give you the same line, even if it looks different in point-slope form. Alright? Let's quickly do this one. Alright, we better do a real-world problem. The boiling point of water at sea level at 0 feet is 212 degrees Fahrenheit. So 0 feet matches with 212. And at the boiling point is 1 degree Fahrenheit for every 540 feet increase in altitude. So now, if you got 540 feet, the new boiling point goes down 1. So it's going to be 211. Tricky. Alright, there's our 2 points. We're going to do the exact same thing we've been doing. We're going to find our slope. Well, our y, if we just look how much it changed from the first point to the second point, it went down 1, right? 212 to 211 went down 1, negative 1. Over, how much did our x change from 0 to 540? Well, it went up 540. There's my slope. I can use one of these points. Doesn't matter which one. Let's use this one because the 0 is a nice number to use. Because if x is 0, that's really my y-intercept. So what they did, if you look at their work here, I don't complicate everything they did, but they just turned this into a decimal. Negative 1 divided by 540 is that. Okay, so that's the number they're putting in there. And then 212 is our y-intercept, because if x is 0, that means this number is our y-intercept. So they put y equals negative 0.002 x and then plus 212. There's our equation. Now, why do they want this equation? Well, they want to know what would it be at 4,000 feet. Well, again, x's are my feet. So I'm going to plug in 4,000 for x and see what my degrees would equal, what y represents. Okay, so that's what they did right down here. This is the final step. They plugged in 4,000 in for x, multiplied and added. 204 degrees Fahrenheit would be the boiling point for that one. Alright, very last slide. We're going to run out of time here. I'm going to cut off at 15 minutes, but this has kind of everything that we talked about this section together. When to use what. So if you're given the slope and the y-intercept, you're using the point-slope form. If you're given the graph, you use point-slope form. Just find a point, or sorry, slope-intercept form. I said that wrong. Slope-intercept. And then if you're given 2 points or a table, you use point-slope. So write down this chart. It'll kind of tell you which formula to use for each problem. All right, thank you. Have a great day.